Welcome back. It's time for another episode of Low Spec Labs. Let's go ahead and let's talk about SmallCTL. SmallCTL is an open source agentic harness created by me, Mr. Low Spec. And SmallCTL basically does a lot of prompt engineering, or I guess context engineering, in order to allow small large language models like Qwen 3.5 9b to actually be useful. And what I mean by useful work is, managing systems, getting information, maybe installing packages or uninstalling packages, right? Basic stuff, nothing too crazy. SmallCTL aims to do that. It also aims to allow you to do all of that inside of a limited context budget. Basically, I came to a conclusion that a lot of people, like a vast majority of humanity, does not have the money for them to go out and buy a brand new 5070, 5080, 5090 in order for them to run 20, 30 billion parameter models locally. What they probably have is an old laptop or desktop with a somewhat working old GPU, maybe some integrated graphics, right? Basically, most of the world is working with potato hardware, which is fine because those small models run reasonably well, even on potato hardware. My harness is meant to try to extend the functionality of those small models a little bit. Not too small, mind you. Once you get down to about 2B, it's too dumb. All right, I've tried. They miss tool calls, which makes the harness more or less useless. But between 4B and I guess about 14 to 20B is like the sweet spot for this, right? Past that, you're better off just going with open code. Before that, it's not even going to work at all. But in that little zone right there, there's a gap. And my harness's goal is to help fill that gap. All right, so we got SmallCTL pulled up behind me. And it's not the sexiest thing in the world, right? I've been focusing more on trying to get the back end working than I have the front end. But it's right. It's okay. It's okay. What we're going to do is start with a simple hello, right? And of course, I'm running this on my own machine. Like the backend model for this is in fact LM Studio, right? As you can see, here's LM Studio right here. And we're going to kick off a quick hello message to SmallCTL. All right. And as you can see, it's kicking off and it's thinking, right? So SmallCTL has a few features. The first is a memory system. So it remembers what it did across runs and tries to save that inside of its memory stores. That's where it's getting this information from. I did a couple runs just trying to do some discovery on my workspace, and that got dumped to memory. So now it always looks for memory, or now it always looks for files on startup. So I guess that's some emergent behavior with a small model. And what I'm going to do is, let's do this. Let's type write a PowerShell script. Write a Python script in /./temp/ that counts integers up to the number 100. So we'll start with a simple script and see how it does. And we'll scroll down and we'll let it run. And it did take a little while. I'm doing this on local hardware, but it said it created a file called countintegers.py. Let's drop from our SmallCTL harness here. And let's do an ls/temp /temp. And we do have a countintegers.py. And then let's cat out /temp countintegers.py. And yeah, that looks about right. From 1 to n, return some 1 to n. So yeah, it wrote the script pretty well. And the idea wasn't to have like a super complicated script. It was just to show you that the harness's features work, and that it does, right? So let's list through the features. All these features more or less had to be added to extend the functionality of the harness. They are not niceties, they are necessities, right? You need them to get some of the results you're getting. Let's go ahead and walk through them as quickly as possible. The first is that it is compatible with open API endpoints. That means LM Studio Llama CCP, Open Router. The thing to keep in mind, though, is this is engineered for small language models. A lot of the stuff I've done to make it compatible with small language models actually breaks it with large language models. All right, so keep that in mind. This is for, I'd say, 20B and under only. But it is compatible with most open API endpoints. So another feature of the harness to help it not destroy its limited context window is that it is not just a chatbot. This provides real tool use and the ability to use it with various phases, right? So it's got a actor phase, a thinker phase, which plans out complex tasks, an explore phase, an execute phase, a verify phase. And the reason it has all of these is because small models are not good at doing all of those at once. So basically what you have to do is take your task, break that task down into various phases, which the model is capable of doing, and then walk the model through those various phases using the harness. So here we have SmallCTL. And let's go ahead and swap back over. You can kind of see the different phases right here. So at the very bottom of the screen, we have our model, which is Qwen 3. And then we have our phase, which is Explore, which is why you can currently see, some file information. It gives you the step count, so how many steps it's taken so far in this conversation. It gives you its mode, which is execution, because it's running tools, and then it gives you its activity, which is thinking. It's not thinking right now, but the model was thinking and it did respond. All right. Then of course we have our chat box at the bottom here. It has a multi-tier memory system, a hot, a warm, and a cold storage. Right. So the hot is for your current chat session. The warm is for your past and most recent chat sessions. And then the cold is all your chat sessions with key details extracted out of them, stuff that worked, stuff that didn't work. I've noticed that one's it needs more refinement, but it's working, right? The alpha ain't going to be perfect. It just has to be good enough that I don't feel embarrassed shipping it out to the public. Another feature we have is gated tooling. So certain tools are only exposed during certain modes in order to try to keep the context window lean. If we were to pull up the harness and then just ask the harness or ask the model, what tools do you have access to in this mode? Let's just give it a second here. And it is done. And it's letting us know it has access to directory list, artifact read, artifact grep, shell exec, task complete, and memory update. So that's basically more or less all the tools it needs in chat mode, right? Like this is regular conversation mode. And then it has additional tools available inside of its actor mode, as well as additional tools available inside of its thinker mode, right? And the idea is to keep the tool calls very small. With large language models, you can have hundreds of tools and the model will be fine as long as your context window is large enough. With this, every additional tool call adds confusion to the small model. So you have to think very carefully. All right. So another feature is auto extraction and compaction. Basically, it extracts the goal of whatever you're trying to achieve from the model's chat messages, and it uses that goal as well as some other criteria to hold that information outside of your current conversation history. Then when compaction happens, it re-injects that information into your conversation history, helping re-steer the model and keep it from drifting. Otherwise, I notice if you just summarize your past X however many conversation turns and try to compress that or compact that, the model starts drifting. Maybe you're like, hey, write a PowerShell script or a Python script that does this. The model goes, okay. And then halfway through, it has to compact. Now, because it's a small language model, its compaction isn't that good. So now the model was going this way and it starts going this way. And you're like, yo, come on, bruh. Come on. All right, so auto extraction of key details as well as compaction help the model stay on task of whatever goal you assign it. And the last step we added to all this is lots of anti-loop guardrails, right? Small models tend to loop a lot, and we need lots of guardrails to keep it from looping, right? Let's see if we can get it to loop here. Let's see. Oh, I know how to get it to loop. Let's see. Do a Google search for the weather and Jack FL. So I do not have a search tool right now, so it should fail out. Let's see what it does. All right, it should fail out and start looping, and eventually the loop guard will kick in and just kill the, stop the chat session, and then we can maybe re-steer it. Oh, this is embarrassing. I asked it to do a Google search and it did instead of looping. So I guess unexpected harness behavior there, right? Just download it and install it, guys. I feel like the best way to learn the edge cases of this harness is to have other people use it. There's only so much I'm willing to do inside of it. I can tell it to install packages and other stuff, but honestly, open code's just really good. I just thought this would be a fun way for me to learn about agentic harnesses, how they work under the hood, and how to engineer one if I ever need to in the future. And having built this one, I do have several ideas, maybe a harness dedicated to Proxmox and a harness dedicated to Intra. Right, I've been thinking about how I would design those two, especially with a smarter model where I don't have to engineer as much around the context, But the link to the GitHub should be at the bottom. Go ahead and download it, run the install script, start up SmallCTL, run it, let me know what you think, and let me know if you want any improvements or changes. This was a fun couple months. I was waiting for smaller models to happen, and they happened within like a month of me mentioning it. Very, very convenient timing. As always, thank you for watching. If you want more of this content, please go ahead and click the subscribe button. If you like this video, hit the like button. Stay blessed, boys. I'll see y'all next video.